Okay, here is the objective of this course. We want to drill down in the field of vectors and try to have a deep understanding and a deep insight of in this field. That is, if we go, for example, in a series of operations handling vectors, what will be the ending result? For example, here we have a gentleman and we want to tell him, hey, please move in this direction for 3 meters. Okay, so but what is this direction? This is the question. We must come to an agreement on how to specify the direction. So let's take a basis or reference to direction. This is a 0 direction. For example, this is a 90 or p half direction. This is 180 direction. This is 3 p divided by 2, etc. So this is our reference of directions. So in this direction, if we want this gentleman to move in this direction, we will give him 2 informations, 0 and 3. For example, if we want him to move in this direction, we will give him, for example, p divided by 2, for example 5. Okay, for example, in this direction it will be something like p divided by 4, for example 6. Okay, now we have a way to define precisely the instruction given to this gentleman. But if we told him 2 instructions, please move in this direction, 0, 3, and then in this direction, and then in this direction, which is 45 degrees, or p divided by 4 and 5. What will be the ending result? Yes, for sure it will be something like that. But what is the characteristic of this vector? Okay, now we shall think a little bit about it. Okay, for this we are going to try to so let's define a vector I, which will help us to calculate all the vectors with a theta equal to 0. For example, suppose we have this vector A. We have A equal to its magnitude multiplied by vector I, which has a magnitude of 1. So all the vectors with a theta equal to 0 in this direction, all the vectors in direction can be written in this form. If the direction is in this sense, this will be in this. It can be written as this. But if the direction is in the opposite sense, we will have A equal to minus a multiplied by I. By the same, all the vectors in this direction, for example, if direction of p divided by 2, which is 90 degrees, all the vectors in this direction can be written as y equal to the magnitude multiplied by a vector g, which is a unit vector. The unit vector is in direction. If u is in the opposite direction, we will have u equal to minus u multiplied by g. Okay. Now, for a vector which is not in the direction 0 or 90 degrees, what will be the easiest way to write it down using I and G vectors? For example, let's say we have this vector A. We can say that A is equal to its magnitude A multiplied by a vector, call it u, with the magnitude of u is equal to 1. So we have a vector u we can write it as u1 u2 u1 plus u2. We have this angle theta, so we have u1, which is in this direction, and we told in the previous page that u1 can be written as multiplied by I, and u2 can be written u2 by g. Okay, so what is the magnitude of u1? It is simple trigonometrics. We have the magnitude of u1 equal to cos theta, because cos theta equal to u1 divided by u. Sinus theta equal to u1 u2 divided by u. So cos theta, cosine theta equal to u1 sinus theta equal to u2. So we have, so let's erase this, let's delete this section. So we have u equal to cos theta multiplied by I since theta multiplied by g. Okay, so we have just proved that for every unit vector u, which is characterized by an angle theta, we can write that u is cosine theta plus sine multiplied by I is sine theta multiplied by g, where I and g are unit vectors. I is characterized by 0, 1, and g is characterized by p divided by 2, 1. Okay, and for a vector which is not a unit vector, we have y u equal to the magnitude of the vector cosine theta I Place sine theta G. Okay,